Okay, so we're going to look at compound inequalities today. So there are two main types. There are and problems and or problems. So we're going to look at and problems first. So as we're thinking about and problems, think about this. Think about if I said for everybody in my class to stand if they were a male and they had shorts on. Okay, if they were a male and they had shorts on. So in order to be standing, the people in the class would have to be male and have shorts on. They have to fulfill both of those requirements. That's the idea of an and problem. So as I'm reading this here, I see that it says -4 is less than r minus 5. And also you have to realize that this r minus 5 is less than or equal to -1. So those are two requirements that have to be met. So first what we're going to do is write the two inequalities separately. Okay, so I have -4 is less than r minus 5. Okay, so that was 1. And we also know that that r minus 5 has to be less than or equal to -1. So all I did was I kept this middle part the same in both of the inequalities, but I put one with this part of the inequality and the other with this. So the middle part always goes with both. The r minus 5 goes with both of the inequalities. And you can kind of see how we put those on each side. So now I just have to solve them. Okay, so we solve those just like we solve simple inequalities. So I would do an opposite operation and add 5 to both sides. And I get 1 is less than r. And on this side, add 5 to both sides. And I get r is less than or equal to 4. Okay, now you can put them back together, but you don't really have to. So we have 1 is less than r, and r is less than or equal to 4. So as I'm graphing this, I want both of my numbers on the number line, the 1 and 4. I think about the kind of dots that I have. So remember, with this less than sign, since it's not, doesn't have the equal to part, that's going to be an open dot. And with this one here, since it is equal to, I have a closed dot. Okay, and then I want to graph the numbers. So remember, I had you think about standing if you were a male and you had shorts on. You had to fulfill both of those requirements. Since this is an and problem, I can only shade the numbers. And remember to read from the variable's perspective. This says r is bigger than 1 and r is smaller than 4. So I can only shade the numbers that are bigger than 1 and smaller than 4. So all of these numbers over here are bigger than 1, and of these, the ones right here in the middle are smaller than 4. So that is the part of my graph that I shade. Okay, so go ahead and pause the video, do the try this, and then you can play it when you're ready to see what I put down. Okay, so I start by breaking my inequality apart. So I'm actually going to zoom in here. So I break my inequality apart with this part and this part, so that I know -3 is less than 2x minus 1, and 2x minus 1 is less than 7. Okay, then I solve both of those inequalities separately. So I would add 1 to both sides and get -2 is less than 2x. Divide by 2 and I get -1 is less than x. Bring down my and then I have to solve the other one. So I'm going to add 1. I get 2x is less than 8. Divide by 2 and I get x is less than 4. So then graphing that, I want to get my numbers on here. So -1 and +4. Make sure you get them in the right order. Then I have an open dot at -1 and an open dot at 4. And then remember, since this is and, I want the numbers that are both. So read this one. X is bigger than -1 and smaller than 4. So I want the numbers that are bigger than -1 and smaller than 4. That would be these numbers in the middle. So I shade in between -1 and 4. So that is an AND case. All right, so now let's go ahead and look at the OR case. Okay, so let's go back to the same scenario that we had earlier. Now imagine I was asking my students to stand if they were female or had long pants on. So female or had long pants on. So right now, there would be all of the females standing, no matter if they have pants or shorts on, and there would be all of the people with pants on, because regardless of if they're male or female, because or implies that I take both groups and kind of lump them all together. So looking at example 2, you'll notice that it already has a word in it, okay, and every or problem will already have a word in it, so it's already broken apart for me. So all I need to do is I just simply need to solve both of these separately. So let me see if I can get rid of this. There we go. Get that out of the way so I can go ahead and solve. Okay. All right, now I'm ready. So I'm just going to solve these two separately. Oops. How do I go back? I guess I just have to erase it. There we go. All right, let's try this again. Sorry about that. Okay, so I want to solve these two separately. So I'm going to bring my OR down here, and then I'm going to solve them separately. So I'm going to subtract 3 from both sides. So I have 4v is less than negative 8. Divide by 4. It looks like I get v is less than negative 2 on that side. Solve the other side, so subtract 7. I get negative 2v is less than, oops, almost messed that up. Is less than negative 6. I divide by negative 2 on both sides, and don't forget your special rule for inequalities. Since I divided by a negative, I have to flip my inequality sign. So this less than sign is actually going to flip to greater than, and then negative 6 divided by negative 2 is 3. Now graphing these, remember when I was talking about people standing up, we had all the females standing and all the people with shorts on. That's an OR case, right? If I said stand if you are a female or you have pants on. All females stand, everybody with shorts on, or pants on would stand. So I get my two numbers on the number line just like I did with my AND case. I go ahead and get my dots graph. So at negative 2, I'm going to have an open dot. And at positive 3, I'm going to have an open dot because neither one is equal to. And now remember, since this is an OR, I'm graphing all of these with all of these. So all the numbers graphed that v is smaller than negative 2. So everything's smaller than negative 2. That's everything down here. And I want to lump together with that everything that is bigger than 3. So I graph all the ones that are bigger than 3. So that's my OR case where I'm taking both of those groups and putting them together on the same number line. So go ahead and pause the video, do the try this, and then you can go ahead and play when you're ready for me. All right, so I bring down my OR, and I solve the two separately. So subtract 2, so 3x is less than negative 9. Divide by 3, and it looks like I get x is less than negative 3. And then solve the other side, so I would subtract 5. So I get negative 4x is less than negative 4. I divide by negative 4. Don't forget about your special rule. So since I divided by a negative, I have to flip my inequality sign, so it's actually going to be x is greater than, and then negative 4 divided by negative 4 is 1. So let's look at my graph. So get my two numbers on here, negative 3 and 1. Make sure you get them in the right order. I have an open dot at negative 3 and an open dot at 1. And now since this is an OR, I want to graph all of these with all of these. So everything's smaller than negative 3. That's all these numbers down here. Together with everything bigger than 1. So that would be all of these numbers up here. So that's an OR case. So now you know what an AND looks like as far as solving, and we practiced graphing last time. You know what an OR looks like as far as solving, and we practiced graphing last time. So you should be good to go with the practice.